Now, I hope you actually tried these problems, my students. Don't just watch me do them. When I say stop and do them, if you're having troubles, especially, just watching me is not going to help you. So you need to actually do the problem, please. So problem 12 says that the recommended angle of elevation of a ladder for a fire engine is 75 degrees. At what height of the building does a 1-foot ladder reach at the recommended angle of elevation used? So actually make a drawing. This drives me nuts. It really does. People will not make drawings. You have to make a drawing of what you have. That is a horrible ladder. You would fall off that ladder. But you have to make a drawing. In fact, on a quiz or test, I will give you partial credit if you just have a drawing that's correct. Now, when you go to geometry next year, or honors geometry, it will say over and over, these are not drawn to scale at all. So a triangle doesn't necessarily, so it says 75 degrees for the angle of elevation. Angle of elevation is always with the ground. And then it says, how high does it reach up the building? So, would the height it reaches up the building, would that be this side or would that be this side? Well, hopefully you noticed it's this side. So I'm going to call that X. Now, what trig function are we using if it's opposite over hypotenuse? Now, I've had kids find this side, this angle, and then go different trig. That's just wasted time, though. So opposite over hypotenuse is sine. So it'd be sine of 75 degrees equals X over 21. So cross multiply 21 sine of 75 equals X. So now, make sure your Desmos is in degrees. That's the little wrench up in the upper right-hand corner. I can't draw it. Oh, that's horrible. Then you go down to functions and trig. So you would go 21 times the sine of 75. I have to go backwards because I'm using an old-time calculator. Because I'm using my iPad right now. And I get 20.27. I like hundreds for trigonometry. I like hundreds. Okay, so I just paused there because my calculator for some reason is starting to die. Anyways, the next problem I gave you to do this morning was problems 35 and 36 on the next page. So, 35, we got squirrels that can fly. Ooh. Adult flying squirrels can glide up to 160 feet. If a flying squirrel glides a horizontal distance of 160 feet and the angle of descent is 9 degrees, find the change in height. So we have a tree. And a squirrel. I'm sorry. That is the worst tree. Now the squirrel jumps out of the tree and flies. So here we got a squirrel. And it's flying. So it goes down. And it says the angle of descent, which is the same as the angle of depression. I don't know why different books make up different names. But it says it's 9 degrees. And it also says that it glides up to 160 feet. Now here's the key thing. It says the horizontal distance. Now is horizontal straight across left and right, or is it diagonal? Well, horizontal is left and right. So if it didn't say horizontal distance, we would have some problems here, because I just spit all over my iPad. Sorry about that. Good thing we are self-separating here, I guess. So the question is, find its change in height. Well, is height diagonal or is it straight up and down? Well, height is straight up and down. So it's opposite over adjacent. So that is tangent. So tangent of 9 degrees equals x over 160. So it'd be 160 tangent of 9. So you got to make sure you understand the words. Now let's see if I can get this. Tan 9 equals, 9 tan. I did it backwards. Sorry. And my calculator is dying. I'm going to have to go out and buy a cheap calculator. Oh no. And I get 25.31. And I get said feet. So in the story problem, you have to label it if it's got it. So problem 36, hang gliding. A hang glider climbs a 20-degree angle of elevation. Find its change in altitude of the hang glider when it's flown a horizontal distance of 60 feet. So, we got a hang glider. It's probably on a mountain. Here's our mountain. He jumps and he climbs. That would be angle of elevation of 20 degrees. Angle of elevation is always made with the ground or the horizontal and up. And it says it flies a horizontal distance of 60 feet. Now again, it's horizontal. Diagonal, is it straight across? Well, it's straight across. Mercy. And it says find the change in altitude. Well, again, whenever you're talking altitude, it's up and down. So that's our x. So what trig function is, here's our angle. Now we could find this is 70 degrees, so you could go with that angle. But what is opposite over adjacent? Adjacent because it's touching the angle. Well, that's tangent again. Woohoo! So tangent of 20 equals x over 60. Now, you could have done cotangent as adjacent over opposite, but if you have a cheap calculator, that's not a good idea. If you have decimosi des, then that is a good idea, if you want. Now, I hope you actually did these problems before you turned me on. So 20 tangent times 60, if you have an old calculator, I get 21.88. And it's feet again. Woohoo! Let me double check it, because again, my calculator is dying, you turkey. Times 60. Yeah, that's what it says. Last problem. Next page. Now, hopefully you have your book out. Number 47 says, Tabitha's eyes are 5 feet off the ground, and she looks up at a bird's nest in a tree. If the angle of elevation is 74.5 degrees, and she's standing 12 feet from the base, what's it say? the base of the tree. What is the height of the bird's nest? Okay, so we have Tabitha. And we have a tree. Whoa. And there's a little birdie's nest on the side of a tree. There's a branch, little bird. So she sees the bird's nest. And this is how far she's from the tree. It tells us that she is 12 feet from the tree. Well, that would be this. And the angle of elevation, I've lost the is 74.5. Now notice again, this is not drawn to scale because 74.5 should be up here. Then it says, what is the height of the bird's nest? So we're trying to find this side. But we know this is 5 from here to here. So we just need to find from here to here. So what trig function, oh my goodness, I'm sorry. So we know from here to here is 5. So we need to find from here to here, then add 5 to it. Because her eyes are 5 feet off the ground. So we can do that because we have our right triangle. So what's opposite over adjacent? Well, again, that's tangent. Boy, these story problems love the tangent, don't they? Equals x over 12. So it'd be 12 tangent 74.5. So make sure you're in degrees. I keep saying it. Times 12. And I get... No, that can't be right. Let's try again. 74.5 tan times 12. Yep, it's 43.2. Thought it was wrong, but I guess it's right. But the answer is not 43.27 because that's a distance from here to here. So I still have to add the 5 because she's 5 feet off the ground. So it's 48.27. Like this is feet too. We hardly ever use feet anymore. Wow. Yep, it's feet. So thanks. I hope you did these before I did them. Take this weekend rest. Don't forget homework was supposed to be turned in last night. And then tonight at 8 o'clock, the 2-problem quiz plus the optional extra credit is due. And remember, the trig, sine is opposite over hypotenuse, cosine's adjacent over hypotenuse, tangent's opposite over adjacent, cotangent's adjacent over opposite, secant is hypotenuse over adjacent, and cosecant is hypotenuse over opposite. Have a good weekend.